Up until now, we have only used one x variable to explain our y variable. So we have explained the variation in wage by using the information from years of education. What we can do is also to use the information in the male dummy to check if there is a difference between the intercepts of male wage earners and female wage earners. To do this, we use the ordinary regress function, and our y variable is wage and our x variable is years of education, and we include the male dummy. We can also use the robust function to ensure that in case there is heteroscedasticity in our residuals, we account for them by adjusting our standard errors. This is our result. We have quite few number of observations, so our F statistic is quite low, and the probability of randomly getting an F statistic more than this is 27%, and this F statistic tests the joint hypothesis that the true value of the coefficient on years of education and the true coefficient on male dummy are equal to 0. And we see here that we would get a joint result equal to 30 and negative 66 by random in 27.5% of the cases. We would get something equal to this or more in magnitude, in absolute value. What we can use now is the wall test to test a combination of the coefficient on years of education and male dummy. So for example, if our null hypothesis is that years of education plus the coefficient on male dummy equal to 100, for example. So what does this tell us? It tells us that given 1 year extra education plus the person taking this education is male, then our null hypothesis is that the wage would increase by 100. And we test this by looking at the F statistic, and we see that the null hypothesis, if we say that this is the population value, then, and given the robust standard errors, what is the probability of getting this result? The sum of these would be negative 36. What is the probability of getting this result given the standard errors? The probability of getting these coefficients, which we got from the regression, is 69.8%. This is the probability of getting this sum or more. So here we cannot reject this null hypothesis because we can't find support for that in our data. And this is a quite simple way to test different null hypotheses, which are combinations of the population parameters.